Going to get started here. Today I'm going to be talking about two OWASP tools that helps with penetration testing coverage. So good afternoon, everyone. So my name is Ken Prole. I wear two hats. I'm the CTO for CodeDX. CodeDX is a system that allows you to bring together all of your application security testing activities, so static analysis, dynamic analysis, code reviews, all into a central console. We have a booth outside, and we can provide some more information on that. I'm also a principal investigator for Secure Decisions. Secure Decisions does research and development in the area of application security. We have some contracts with the Department of Homeland Security, and the tools I'm going to talk about today were funded through the DHS. CodeDX itself was also funded initially through DHS, and then we transitioned that into a commercial product. Secure Decisions is a division of Applied Visions. That's the parent company. It's been around for over 30 years. They do custom software development. I'm based in New York. I am the project lead for the two projects I'm going to talk about today, CodePulse and Attack Surface Detector. I've been in software development for over 20 years. I started out doing C++ development, and most recently being helping people develop more secure software. So a quick agenda. I'm going to talk a little bit about the tools from a high level, talk about the white hat penetration tester, what the typical workflow is like, and we're going to talk a little bit about the attack surface and what that means and how these tools can help with that. So the two tools, we're going to go into depth onto that. OS CodePulse, we can talk about the challenges it addresses, how it works, provide a short demo, and then the attack surface detector, just going through, what's its purpose and give you some highlights of the features. And finally wrap up where to learn more information and do some Q&A. I hope that after this talk, you'll be able to see how these tools can help make black box penetration testing less opaque. All right, so an overview, the two projects are CodePulse and Attack Surface Detector. I've been to several talks where a lot of projects are kind of really early on. These are pretty mature projects. They're both OWASP projects, open source, freely available. CodePulse has been around for about 4 years. We just recently made a lot of improvements to it. It's basically a way to instrument an application while it's being tested and get a sense for how much code coverage you're getting. The Attack Surface Detector is also an OWASP project. We actually collaborated with Denim Group initially on this effort through the DHS contract, extending on some of the work that they've done, and that helps you figure out the attack surface that's exposed in the application. We're going to go into more depth about that. The output of that can be used to precede tools like ZAP and Burp so that it can have a better understanding of the application and do a more thorough testing. And we actually use the attack surface now within CodePulse, and I'll demonstrate that as well. So these two are working together. All right, so white hat penetration testing, that's the core users that we're addressing, also known as ethical hackers or OWASP speak. They're the breakers, the ones that go in and try and attack an application. Anyone here consider themselves a white hat pen tester? Okay, awesome, cool. So you have some disadvantages, right? Your job is to find all of the vulnerabilities where a hacker just has to find one, and you have limited time compared to what the hackers have out there. And if you're working closely with the development team, it's hard to keep up with them, right? They're developing code really rapidly, and that's a challenge. So there's a few advantages that you can have if you have access to the bytecode or the source code. These tools can help out with that. And I'll also talk about some ways around that if you don't have direct access to the source code. Anyone here familiar with ZAP? Okay, cool. Burp Suite. Actually, these are really popular penetration testing tools. They can be used manually or automated. A lot of the solutions I'm going to talk about today can also work with tools like WebInspect or Acunetics or NetSparker. Or even just doing strict manual reviews, or if you have an outside penetration testing organization that is doing testing for you want to get an idea of how much coverage you're getting, these tools can help out with that. So let's talk a little bit about the typical workflow for a penetration tester. You have a web application that's probably accessing some database where you have your sensitive information. As a pen tester, typically the first step is to try and figure out how to authenticate. You have to know the different users and different user roles that are associated with the application. If you don't have the right credentials, you're not going to really get too far with being able to test the application. And then do endpoint enumeration. So a lot of times you'll manually map out the application, go to every single link on the page, go through the forms, go through multiple step forms like checkout processes, have multiple steps so that you can build up that sitemap in order for the tools to perform their testing and for you to do more thorough manual testing. Then typically go through the automated spidering and crawling process. So tools like Zap and Burp, you can just point them at the website. It'll automatically figure out all of the different endpoints. And the better you do that manual mapping, the better the tool will be able to do to crawl out further. Then you can do brute forcing or forced browsing. So this is a way of the tools trying to find unlinked endpoints in the application. Basically, there's a dictionary of different keywords that it'll try and put on the URLs that other apps might use. But a lot of times this is hit or miss if you're going to be able to find one of these hidden endpoints. From this endpoint enumeration process, out pops the attack surface. So the attack surface is how an attacker can get into the application to get to the sensitive data that you're trying to protect. And once the attack surface is out there, then you can go through the vulnerability discovery process, doing passive, active, or fuzzing. Let's talk a little bit about the attack surface a little bit more. I'm going to use a house as an analogy. So if you look at a house, how can someone get into your house? Maybe they'll try the front door, the side door. They'll look for open windows. So these are ways of getting in and getting to sensitive information. With a web application, that's typically the URLs that the application is exposing, like a login form. And depending on how that login form is used, the attacker can get into the application in different ways. But the open window is just kind of the starting point for getting at the sensitive information. There's different paths that one can take through a house or an application to get to that particular area of interest. For web applications, though, this is much more complex, right? It's not a single floor. Much more complex. You have many floors, and being able to, if you look at this as an application, how can you know how much coverage you're getting and where you're going within the application when it's this complex? So this is why we developed OWASP Code Pulse. If you look at Wikipedia under Web Application Security Scanner, you'll find this. It wasn't written by me. The penetration tester should look at the coverage of the web application or its attack surface to know if the tool was configured correctly or was able to understand the web application. And this is really what Code Pulse is aiming to address, being able to measure how much coverage you're getting during your penetration testing activities. A lot of times, if you're just looking at what you can see, you don't know what you can't see. So Code Pulse helps with several different things. It'll tell you if you reached all of the application. As you're doing actions within the application, you can see which parts of the source code were executed. So similar to the house analogy where you're performing different ways of trying to get in and how you can get different parts, the same thing you can do in real time to be able to see how much coverage you're getting and where you're going within the app based on the actions that you're performing. You'll be able to compare different tools to see which ones are getting better coverage. If you have multiple testers that are doing testing, you can compare how well they're doing or which parts of the app they're testing more. Most important, it helps you tune your test coverage, your testing tools. So a lot of the tools need to be tuned for the application or just tuned for themselves to get better coverage. You can use that for this. And then communicate the testing coverage to others. So, helps with coverage gaps, tuning the applications and tools, and then communicating the results to others. So Code Pulse is primarily a code coverage tool. Now there's other solutions out there that will be able to check code coverage, but this was really developed specifically for penetration testing activities. The other tools are primarily static, where you do all your testing and then you come back and you look at kind of a flat list of what was covered. But Code Pulse is a real-time and very visual presentation of the application under testing. And the old adage that a picture's worth 1,000 words is something true for what we're doing with Code Pulse. And it allows you to really see the whole application in a single view. So in a nutshell, Code Pulse is a real-time code coverage visualization tool for penetration testing activities. So how Code Pulse works, and you have your penetration tester looking at an application. In this case, it's WebGoat, and that's a black box perspective. You can't really see what's going on inside. With the Code Pulse agent, you install this within the application. We have support for Java and .NET. And what this will help you provide is real-time code coverage information. So turning that black box into a glass box so you can actually see what's going on inside. So that provides transparency, it provides feedback into your testing, and helps with tuning your testing to get better coverage. So this is a picture of Code Pulse. Each box here represents a method within the application, and it's grouped by the classes and the namespaces that are involved. And as you test the application, the boxes will highlight, and just like in the house scenario, you'll be able to see where within the application you're going during your testing activities. So this is kind of like a blueprint for your software. So let's look at a coverage scenario. I took WebGoat and OWASP Zap, and I was monitoring it during my testing activities with Code Pulse. I launched Zap, I pointed it at WebGoat URL and let it do its spidering, let it do an active scan, and this was the coverage I got. It's cutting off a little bit. Well, yeah, just within a box. Yeah, there's one box here, one box here, one box here. And if you look at the tooltips on this, you can see that it's the index JSP, the login JSP, and the login controller. So because I didn't log in to WebGoat Zap, did all its testing, ran for a few minutes. You might think that you tested the whole application, but really you didn't do anything at all. You just tested the login page, and you weren't able to break that. So then I went and I logged in through Zap, so now Zap knows how to log in, and I ran the spider and ran the active scan, and this was the map that was generated. So I got, I did a better job, I got some more coverage. Then I did manual browsing. I went through WebGoat, went through a bunch of different forums, and then now you can see that the picture's getting better, right? So I'm getting a lot more coverage. And I could still look for areas that I may have missed. Like in here, there's in this admin class, there's a refresh database screen. I never went through that particular action, so Zap wasn't able to get into that part of the thing. So looking at the overall results of these, this is the first scan, second scan, and third scan. So now visually you can see that I'm getting better coverage just with this tool. You could also use it to compare manual and automated scanning. So within Code Pulse, you can have different recordings, and in here, basically everything that's black is saying that it was found both by manual and automated testing. The things that are in green were just found during my manual scan, and then the things that were in blue were just found by automated scan. So it allows you to compare different testing approaches and kind of get an idea where there's overlap. You can compare tools, so maybe running two tools or evaluating tools. You can see how well they're performing. So in this case, it's the same kind of thing where the black is found by both, and then the colors represent what was found by the individual tools. Compare testers. If you're hiring an outside firm or you have an internal testing team and you want to see how much coverage they're getting, you can instrument the application and see that. So now I'm going to go to a live demonstration. Here I'm going to use Contoso University, which is a sample application for Microsoft. It's built on the ASP.NET framework. And so this is Code Pulse. I've given Code Pulse the binaries and the source code for the Contoso U application. You don't need the source code, but if you provide the source code, you'll have some additional information that I'll show you here. On the left is the application inventory. This is all how the application is broken up into different namespaces. We also integrate dependency check, and so you can drill on that. You can see any dependencies that this application makes use of. That can be used full for a penetration tester to then try and exploit those vulnerabilities, like the Apache struts or some other vulnerability that is known. As a pen tester, you can go in there and try and exploit that. So here I've highlighted the main package for Contosa University, and you can see, you know, again, all these boxes are all the methods, and they're grouped by where they are in the application. You see this whole box here is all migration classes, so that's probably not of interest, since that's not something that can probably be touched from the outside. Some stuff getting cut off again, but and then you see here that these little icons, this indicates what we have identified as the attack surface. So this is utilizing the other tool I was talking about, the attack surface detector. So you can highlight what are the entry points, what are the open windows for this application that an attacker can get into. All right, so I'm going to now instrument the application, and CodePulse is saying, you know, do you want to associate it with this particular project? I've gone in and did that, and just going to bring up browser here. All right. Let me get rid of, let's focus on just the controller package, which primarily is the attack surface for this application. So IIS is going to wake up here, and as the application is loaded, you'll see some things highlight in real time. So, you know, we just hit some methods here, and this is the home controller index method. So this particular application, you can create the departments and instructors and students you can add and delete and stuff like that. So as I interact with the application in real time, you'll see things start to highlight. I'm actually going to start a recording. We'll call this manual scan. So I'm going to look at the courses, and you'll see here this kind of represents all of the courses methods. And as I start interacting with this application, you'll see the coverage start improving. So we're going to add a new course to this college called AppSec. It's a 3-credit course under the computer science department, and boom, so now I've hit some of those methods. We're going to go in and let's change we'll edit it, we'll make it a 4-credit class instead of 3. And let's get rid of calculus, that wasn't fun. Get that. All right, so now we're getting some more coverage. I can look at the details. So pretty good here. So now we've covered just about all of the methods, although we missed one, and that's the update course credits method. Now this I didn't put it in there, this is from the Microsoft application. This is an unlinked endpoint that you wouldn't be able to find just by navigating the application. So I could actually go in here, and then because I know it's called update course credits, so you see that index there. This basically allows you to change the number of credits. You can multiply it by 2. Now I've gotten full code coverage. Although that's just saying at the method level. We now have the ability to go into the line level information. So let me go back out here and look at the edit method. So this is to edit a particular course. You see we hit some lines here, but we got 5 out of 7 statements. So let's try and improve on that. So we see, let's see, go back to departments. Actually, courses and edit. So you can see up here it takes in parameter, which is the ID, which is what it's looking for here. Now, if it doesn't find the ID, it's going to go through a different code path. So if I put in 1000, which I know isn't an ID that's going to come up as null. So now we're entering different parts of the application, and this is a known, it's going to throw an error saying it couldn't find that. If I put in null, you're going to see that it's going to try and find that ID, and it's not going to find it, and then in real time, you'll see that that information gets highlighted in the source code. So let's stop this recording and start another one where this time I'm going to run Zap against the application. So I have Zap already set up to connect to this particular app, and we're going to spider it. So you see that, you know, Zap is going through its spidering process, a whole bunch of boxes are lighting up, and you know, again, you can see in real time how much coverage you're getting. And once that's done, which is just about done now, I can stop that recording and now compare that to my manual scan that was done. And you see Zap, you know, Zap found a lot of things, but it wasn't able to find that unlinked endpoint, the update course credit that was found during the manual review using the tool. All right, so that was Code Pulse. Now I'm going to switch over to the attack surface detector, which you saw a little bit in Code Pulse, where you're able to highlight the attack surface part of the application. So the problem that we're looking to identify is to improve the attack surface, you know, particularly the endpoints that are undiscoverable by dynamic tools, unless you're using brute forcing or if you're going through and looking at the source code. So we have an open source solution that will help identify the attack surface, and that can be used to precede tools like Zap and Burp. So it helps abbreviate the testing process. Again, you don't have to do brute forcing. You don't have to go through a manual code review. It'll help discover unlinked endpoints. So just like we saw in that sample application from Microsoft that has an unlinked endpoint that it would be extremely difficult to find with other means. And also optional parameters, like if you have a debug parameter that's being added to the application, you'd be able to see that, as well as the data types associated with it. So just by running the attack surface detector, you get all that information about the attack surface. That can then be used to precede tools like Zap and Burp with the attack surface. There's plugins available for both of those tools. And then you can also take a look and compare different applications, different versions of applications to see how that application has changed between different parts. So how it works, it analyzes the source code. So the source code is required, and from that is able to figure out all of the endpoints and the parsing routes for the application and then the parameters that are available. These are supported frameworks, languages and frameworks, so .NET, Java, Python, Ruby, and it is framework dependent, so these are the frameworks that are currently supported. It is available today in the OWASP, Zap, and Burp Suite marketplace, so right from within those tools, you can go in and add this plugin and then improve your attack surface detection. Once it's installed, this is looking at Burp. You'll have a new tab within Burp and Zap that called the attack surface detector, and then there you can, you know, tell it, give it a zip file of your source code. If you want to compare it to another version, you can give that here. What you get from that is a list of the endpoints. This is again using the same Contoso University application, the number of parameters that were detected, whether it was a get or post method, and whether it was changed between the last version of it. And then on the bottom, you can get details about the particular endpoint. You know, this one was a new one. We have another example where the ID data type changed from integer to string. Another one where a debug parameter was added to the endpoint. And then all that information can get fed into Zap or Burp, so it can improve your sitemap. And then you can also see we have color coordinated way of seeing, you know, whether it was detected by source code, whether it was modified, or whether it was new since the last scan. So now this allows Burp and Zap to have a more intelligent way of doing its analysis, since it's being told a lot more information than it would be able to discover otherwise. So running this against Contosa University, there's more, after going through the attack surface detector, there's more endpoints that were detected. There's the update course credits again. That was the unlinked endpoint that was found during the attack surface detector. There's a delete and edit endpoints that weren't detected, and that was because when I ran this, there was no data that was already part of the application, so those endpoints weren't able to be discovered by Zap or Burp. So looking at a comparison, this is a report generated by Burp Suite. You can see, before the preceding, these are the number of URLs that were detected and parameters, and then after, just by doing the preceding, we were able to improve that and find a lot more endpoints and parameters that now can be tested. And then bringing this back into CodePulse, we were able to take a look, with and without the attack surface detector. So again, the overlap is shown in black, and then the things that were discovered after using the attack surface detector are all shown in blue here. So we're able to visually show that you're able to improve your code coverage by using this technology. And also in CodePulse, you can see a bar graph of the code coverage. And again, looking at the controllers, which is the attack surface, before the attack surface detector preceding got 46%, and then after we were up to 75%. This is a report that was done for a more complex application. So Contosa University is pretty straightforward. This was a proprietary application that we ran Burp against. So this was just using Burp. This is just using the attack surface detector to discover the attack surface, and we found a lot more. And then this last one here is first using the attack surface detector and then going through the Burp's discovery process and what I was able to find. So the best way of doing it is to first have the attack surface detector integrated and then go through the crawling and automated scanning from the dynamic tools. Lastly, one of the problems with the tool is, a lot of times pen testers don't have direct access to the source code. What we provided is a command line interface that can be used so that you can give this to the person that owns the application. They can run this CLI tool against the application, and a JSON file will get generated that just lists out the endpoints and parameters that can then get fed into Burp or Zap. And so they don't have to give you the proprietary source code. They can just give you this attack surface discovery file that can then be used into the Burp and Zap. I'm just going to wrap up and I'll take some questions. This is a couple more slides. Where to learn more about these projects. CodePulse Attack Surface Detector are both OWASP projects. From there, you can find out all kinds of information about them. The GitHub repos, the user guide and documentation are all linkable from there. We talked about OWASP Zap and WebGoat and Dependency Check. Those are all really good OWASP tools that were demonstrated today or integrated with the technology. The Contosa University application that I used for the demonstration is shown here. And finally, linked to Burp Suite, which was highlighted during the demo. And now I'll take questions. I'm really interested in any feedback you guys have. Please reach out to me directly. We can walk through a demo. I'm at the CodeDX booth. We can talk more. Really interested in getting feedback from the community. Do you want to use the mic?
So you mentioned you need the source code to do the surface detection. Can we just, for Java, just use a jar file? It's just, you have to.
If the jar file has a source embedded in it, then that would work. Yeah.
Okay.
But it doesn't.
But it doesn't do the decompile.
No.
Swagger.
That's a good idea. Yeah, no, that's a good feedback. Yeah, not now, not currently, but that's a good idea. I'll make a note of that. Thank you. Oh, yeah.
Hello,
Hi.
thank you for this talk. That was very nice.
Thank you.
I have a question. What is the benefit of the attack surface detector if in the end of the using of code pools you will find out all the entry points? Like you're browsing the applications and you see on the code pools those parts which you are like triggering. So you know that these are entry points.
Mhm.
So in the end of using, you will get all this information. Why do you need a surface detector?
Yeah, I mean, they're complementary. The attack surface detector, the nice part about that is you can just feed that into Zap and Burp directly. So it's a little bit more automated in that way. Where Code Pulse, it's more interactive and you're exploring around and trying to improve your coverage that way. And Code Pulse does require that you instrument the application in order to do that testing coverage, which isn't. Yeah.
Okay, thank you,
Yeah.
thank you.
Hey.
I have mainly two questions. So, yeah, first of all, they're really cool project.
Cool, thank you.
For contributing to OWASP. So the first question is, if you notice like Burp and SAP, they're moving towards continuous integration,
Yeah.
continuous testing. Do you have any plans to move these two projects for a continuous integration?
Sure, that's a good question. Yeah, that's probably the highest thing on the roadmap is to fit better within the automated process and CI process. The attack surface detector is a little bit easier in that way. You can you use that CLI tool, as part of your CI process to show the endpoints and the differences in the endpoints between them and feed that into Burp and Zap. But we're looking to make that a little bit more seamless. And then certainly with Code Pulse as well. Right now it's more hands-on and interactive, and we're looking to make it work in an automated way.
Yes.
Yeah.
Second question is, like you mentioned about there is a Department of Homeland Security funding for, so is that for both projects? And
Yeah.
is there any, if you don't mind, can you let us know the scope? Is there any license restriction for any companies to use or any kind of mess behind this funding and problems?
Yeah, they're both funded through the Department of Homeland Security. They're Science and Technology Directorate under the Cybersecurity Division. We are working on other projects as well. So if you check out the Security Decisions website, you'll see some other projects that we have in the area of application security. Both of these projects are open source. Code Pulse is Apache license, and the attack surface detector is the Mozilla public license. Yeah.
Both are Apache. Okay. Thank you.
Yeah, you're welcome. Thank you. Hey.
Hi, it was a really interesting set of tools, and I wanted to ask what kind of support would there be for single-page applications, since there's not so much crawling that has to be done?
Yeah, that's a good question. For Code Pulse, you'd be able to see it down to the method level, so you'd be able to, look in more depth. Yeah, I'm not sure how the attack surface detector would work on single-page apps, but I know that like for any web APIs and all that stuff is all supported by the attack surface detector. So,
Thank you.
thanks. All right. Thank you, everyone.